Hello and welcome to some notes on physics. These notes are going to be about one-dimensional motion. And I know earlier in the semester we talked about one-dimensional motion, but that was horizontal motion. For this unit we're going to be looking primarily at vertical motion. And for this part of the unit we're going to talk about one-dimensional motion. In these notes we'll be dealing with objects that we will call projectiles. A projectile only has gravity acting on it. The path of a projectile is called its trajectory. The peak, or the highest point of the trajectory, is called the apex. So in our unit on forces, one of the things we did is we illustrated the forces acting on an object by drawing vectors, and we called that a free body diagram. So if this object right here, this projectile, this blue projectile, was going to have a free body diagram drawn on it, how many arrows would it have? If you said only one, you are correct. Since this is a projectile, the only force acting on it is the force of gravity. So the only arrow we would draw is the weight force. There is no normal force because there's nothing supporting it, and we're not going to have any horizontal forces acting on it, so we won't have an applied force or a friction force horizontally. So only a weight force. Hopefully, if you're looking at the diagram on the left, you'll see the position of the projectile at 1 second intervals. And hopefully, it'll be very apparent that if you see these numbers right here, these are distances. So your answer would be no. The ball continually travels a greater distance per second. Again, thinking to the previous slide, if the ball is traveling a greater distance per second, would you assume that the velocity is constant? Again, I hope you said no. The only way the projectile can cover more ground, more distance per second, is if its speed or its velocity is increasing. You might notice the negative numbers here. The negative numbers imply that the object is going down. We'll talk about this a little bit more, but as you can see, if the object fell for 2 seconds, it would have a velocity of 20 meters per second. So what's causing this? The force of gravity is causing this object, this projectile, to accelerate. And is the acceleration constant? You bet it is. The acceleration is -10, negative because downward, the whole time the object is falling. Since the object is not changing mass and the Earth is not changing mass, the acceleration, the gravitational forces between the objects will remain the same, therefore the acceleration will remain the same all the way down. Now this looks very confusing, but actually, think about this is a formula we've already had. Acceleration equals the final velocity minus the initial velocity over time. And we've even worked this formula before where you guys were asked to find the final velocity. But the goal of these notes is to help you not only describe what's happening to the velocity and the time and the acceleration and the distance traveled of a falling object, but also to calculate these things. So I hope you copy this formula into your notes and onto your notes page. So one more thing before we work some sample problems here. If an object is falling and the only force acting on it is gravity, the acceleration that we're dealing with here is -10. So if the only thing that's causing it to fall is the acceleration due to gravity, wherever we see the A, we can substitute the negative 10 for gravity. And we're reminding you that the negative 10 is just because it's falling down in a downward direction. Distance is a little more complicated. We recognize all the letters. D equals initial velocity times the time that it falls, plus 1/2 times the acceleration, and the acceleration is usually due to gravity, times the time squared. It looks complicated, but fortunately you won't have to memorize this formula. You will always be given enough information to be able to solve for one of those variables. So here's a sample problem. If we go to downtown Atlanta and we drop a watermelon off the Sundial restaurant and it takes 3 seconds to hit the ground, we should be able to find out a lot of information about that watermelon with only knowing its mass and the time that it took to hit the ground. So let's look at these problems. So we have the watermelon, and we want to know what its velocity is when it hits the ground. So let's go back to that first formula. VF is equal to the initial velocity plus the acceleration times the time. Well, the initial velocity of that watermelon is 0. It was dropped from rest. And the acceleration is negative 10. That's because gravity is the only thing acting on it. And the time that it took to hit the ground, according to the problem, is 3 seconds. So pretty straightforward. Our answer is negative 30. Now if we were talking to somebody, we wouldn't say that it's negative 30, but the negative implies that the object, the watermelon in this case, was falling in a downward velocity, and therefore we have the negative sign. Eventually, we might have problems where things go up and down, and so we'll have positives for an upward direction and negatives for a downward direction. The second part of the problem was how far had the watermelon fallen when it had only been fallen for 2 seconds. So this is before it hit the ground. So we have distance is equal to the initial velocity times the time plus 1/2 AT squared. So let's put in all the numbers that we know. We know that the initial velocity is 0. The time is 2 seconds. Gravity is still negative 10, regardless of whether it's hit the ground yet or not. And the time is 2, and that's going to get squared. So let's simplify a few things. 0 times 2 is 0. 1/2 times negative 10 is a negative 5. And then 2 squared is 4. So our answer is negative 20. Now in this case, the negative just implies that the watermelon is 20 meters below its starting point. If it had been a positive 20, we might think about the idea of throwing the watermelon up in the air, and it would have a positive height. The third question was, how tall is the sundial? Now that's another distance question. So again, distance is initial velocity was still 0, dropped from rest. The time is now 3 seconds. Gravity is negative 10, and now the time is 3 seconds, and we only square the time. Do a little simplification. And so now we see negative 45. Now in regular conversation, we probably wouldn't say a building is negative 45 meters tall. So it would be very appropriate to go ahead and just keep that a positive value since it's 45 meters above the ground. And then finally, what is the weight of this watermelon? And this is a very familiar formula. Weight is same as before, mass times gravity. So we have the mass, and we're going to actually keep the gravity positive in this scenario. And the only reason we're going to keep it positive is because usually when we talk about the weight of an object, we don't really say that it has a downward weight. So this watermelon has a weight of 30 newtons. But if we wanted to be technical, negative 30 would be just fine. Now that's also going to be the force that it has when it hits the ground, because the weight of the watermelon is the force of it. So here are a couple of things to keep in mind when we're talking about a projectile that's freely falling. Gravity is the only force acting on it. That's the only thing that's making its velocity change, but the gravity stays the same. We're also going to assume in this whole unit that there's going to be no air resistance. So acceleration will always be negative 10. An object will not reach its terminal velocity in any of the problems that we're dealing with. For this part of the notes, the initial velocity will be 0 if an object falls from rest. And these are our two formulas. Notice how I went ahead and substituted a G for the A, just to kind of show you that the only thing causing the acceleration is the acceleration due to gravity because of the attraction of the gravitational forces. So here's a couple of questions that don't have any math, but let's see how you do. So when an object is freely falling, what happens to the velocity? If you said yes, you're right on target. And the answer is yes, it changes 10 meters per second for every second that it falls. So in the first second, it would be 10 meters per second. The second 20, the third second, 30 meters per second, and so forth. Hopefully here, you said no. If the velocity is increasing, then it's going to be covering more distance in the same amount of time per second. If you're traveling 20 meters per second and someone else is traveling 30 meters per second, you're obviously not going to go the same distance. So if you're continuing to get faster, you're going to cover more distance per second.